find the slope of the tangent like we've done before. This is a trick question in a good way. What I mean by that is if you're very sharp, you can see the answer to this already without even using the formula. But I'm going to pretend that I didn't notice that, and let's see how the formula does this for us. We do the limit as h goes to 0 of f of x plus h minus f of x all over h. And to get this filled in, we need f of x, and we have it. It's 3x minus 4. We also need f of x plus h, which means write this again, but everywhere that it should contain just an x, we put x plus h instead. And that cleans up to 3x plus 3h minus 4. So that's our f of x plus h. Now that we have that, we can set up our limit formula. The limit as h goes to 0 of f of x plus h is all this stuff, 3x plus 3h minus 4, minus f of x is 3x minus 4, they say, all over h. Now, how much does that clean up? I see 3x minus 3x, that can go. I see minus 4 plus 4, that can go. So we're left with the limit as h goes to 0 of 3h over h, which is simply 3. Is that right? There isn't even an x in this. Does that make any sense? Well, yeah, it does, because what kind of function is this? Y equals 3x minus 4 is a straight line with a y-intercept of minus 4 and a slope of 3. And it has that same slope of 3 everywhere. So when we run this through the formula, it spits out, yeah, the slope is 3. I don't need to know what your x is. I don't care what part of the line you're on. The slope is always automatically 3. So this thing really does work. And we could have seen that 3 coming if we'd recognized that this was a straight line. If you did spot that, well done. If you didn't spot it right away, no big deal, but I hope it makes sense to you now that with a straight line, this formula says I don't need to know your x value or anything else. The slope is 3 everywhere. So when x is 2, the slope is 3. When x is 5, the slope is 3 again.